Hi, I am Varsha and this is my project titled Pronunciation Scoring. In this project, I built a system that automatically evaluates how close a user's spoken English is to native pronunciation using deep learning, pitch analysis, and alignment technique. Learning pronunciation accurately is difficult, and human feedback isn't always reliable or immediate. So, wanted to build a system that can automatically access pronunciation and give feedback on where the speaker is doing well or needs improvement, all in real time. My system records the user voice, generates a reference native audio using LibriSpeech dataset, align both with text using Montreal Forced Alignment, and then compares them using two main techniques: GOP for pronunciation and DTW for fluency and pitch. Finally, it gives personalized feedback. Here's how the system works step by step. The user records their audio and we generate a native reference. Both are aligned using MFA. Then we extract the relevant features like pitch and phoneme boundaries and compute various scores. Finally, the system prints a comprehensive report. GOP, goodness of pronunciation, checks how likely a spoken phoneme matches the expected one. The implemented both the traditional GOP and improved context aware version that uses smoothened long probabilities. These are derived from the wave to vector acoustic model using PyTorch and torch audio. DTW or dynamic time warping compares the pitch and fluency of the user's speech with the native audio. I implemented DTW on raw pitch, on pitch deltas, and on energy changes using Parselmouth and Librosa. These gives a detailed fluency scores that reflects natural speaking rhythm. To know where each phoneme start and end, I use Montreal Forced Alignment. It takes the user's audio and transcript and generates a text grid file with timing. This is essential for calculating individual phoneme scores. This is our experiment output. It shows pronunciation and fluency scores and gives feedback on each phoneme and suggests tips like speak slowly or mimic native tones if needed. It also evaluates how accurate each word was and gives an overall sentence score. As you can see here, the sentence score, the word score, and the phoneme level score, and the fluency score of the person on basis of intensity, pitch delta, and autocorrelation. And I have also calculated the scores based on traditional GOP and improve context aware GOP and the DTW score. Now we will see the experiment. Now I'll explain my code. First, I have imported all the necessary libraries. This include PyTorch and torchaudio for deep learning based audio modeling, Parselmouth for pitch and intensity analysis, Librosa for DTW, and other tools like gtts and pydub, and keyboard for TTS and user interaction. After this, we define path for storing user and native audio and load the pre-trained wave to vector to model from torch audio. This model is used later to generate phoneme emission probability for GOP scoring. This is how we are handling the audio. This function keeps listening for key presses to trigger uh, recording and stop recording. It uses multi-threading so recording doesn't block the program. After this is my traditional GOP score calculator, and this is the code for context aware GOP score. Here we are doing the autocorrelation for DTW. Here we are doing the pitch delta extraction for DTW, and this code tells how the fluency is calculated using DTW. This part of the code do the force alignment using MFA. This code tells the phoneme score for each phoneme, and this is the code for our feedback report. And these are some small codes to get the accuracy and to get the scores for each word and ultimately calculate the score for whole sentence and finally get the whole report from the calculated scores. The main function first downloads the LibriSpeech test dataset to get the native voice, and then the transcript is printed, and we can also listen to the audio so that we can mimic that. After that, the user records their audio, and the all the scores are calculated, and finally the report is printed. Now I will run this code. I have created an environment. Now I will first enter in that environment. Now I will run my scoring Python script. This will download the LibriSpeech dataset to get the native speech from that, and it also.
She is wonderful, more wonderful than anybody we've ever seen anywhere, and she draws better than the teacher in Charlestown.
This is the audio we have to mimic. We have to speak like whatever they are speaking. We have got the transcript. This is the transcript what we have to record, and we have listened to the audio how we have to say it. So now we will record it. She is wonderful, more wonderful than anybody we have ever seen anywhere, and she draws better than the teacher in Charlestown. Now we have recorded our audio, and it will process the audio and get the GOP and DW scores and the report and all the phoneme score and world level scores for our audio. We can listen to native audio from here.
She is wonderful, more wonderful than anybody we've ever seen anywhere, and she draws better than the teacher in Charlestown.
We can also listen to user audio. She is wonderful, more wonderful than anybody we have ever seen anywhere, and she draws better than the teacher in Charlestown. This was the transcript. Here we are getting the MFCC feature. So we are doing forced alignment. This is a first pass alignment. This is second pass alignment. And now we are getting the scores. So this is our score. How my intensity matches with the native intensity. This is the pitch delta and the autocorrelation. How the both the audio with the spaces, how they match. The accuracy of my speech, traditional GOP score of my user audio, the context aware GOP score of user audio, and here is an improvement of approx 2%. So we have computed that our traditional and the improved GOP scores have approx improvement of 3% to 6%, and this is our DTW score. And we can combine both the scores using variable alpha. Here we have taken 0.5. This is our phoneme score. The phoneme have a 99.91% score, and similar to that all the phoneme scores are listed here, and all the word level score, finally getting the sentence level score. And this shows that our user audio is good at pronunciation but lacks in the fluency and pitch. So we have to improve our fluency and pitch. So our experiment, I have shown my experiment and how we get all the scores, the fluency scores on the basis of 3 DTW scores, the intensity, pitch delta and autocorrelation delta. So the fluency is analyzed using 3 DTW based method: intensity, pattern, pitch deltas and rhythmic autocorrelation. Phoneme accuracy is measured using both traditional and context aware GOP, and the improved GOP score uses context aware modeling and gives about 3% better accuracy than the traditional version. So to conclude, we have developed a hybrid pronunciation scoring system that uses both GOP for articulation and DTW for fluency. The improved GOP technique outperforms the traditional approach by around 3% to 6%. It evaluates pronunciation on phoneme, word and sentence level. One key is feature is real-time feedback with explainable results, sometimes that learners can truly benefit from. The system also allows tuning of alpha to balance fluency and accuracy based on your usual goals. In future, this can be extended to tonal language and developed as a web tool. Thank you.